Now consider the binary semaphore. So what is the meaning of binary is 2. So what is the difference between counting semaphore and binary semaphore is, in counting semaphore we are actually counting what? If the value of counting semaphore is positive, it is nothing but how many processes can enter the critical section, and if the value is negative, it is nothing but how many processes have got blocked, and how many processes are present in the block state, right? That is what we are counting. But here using binary semaphore we will not be able to count, right? Which means it is just used for operation but then not for counting. So let's see this. Binary semaphore, struct binary semaphore, it is a structure which contains two values. One is a value whose type is, whose value is enumerated to be 0, 1. This enum means enumeration. Okay, we shall see it in C programming language. For now understand that whenever I write enum followed by something, it is enumeration. It means that this variable value can take only these two values, which means we are defining a data type where this data type will take only 0, 1. It is something like int we are defining, right? But then it can take only 0, 1. If you try to assign anything other than 0, 1, you will get an error. So now since it is a binary semaphore, it is going to take only two values, 0 and 1. 1 means it is available, which means whoever tries to do down on this can enter the critical section, and if it is 0, it means that already someone is inside the critical section, therefore you are not supposed to enter. So it is strictly used for mutual exclusion. Mutual exclusion means only one process can enter the critical section, isn't it? So you can consider this to be a counting semaphore whose value is initialized to 1. Whenever a counting semaphore value is initialized to 1, then only one process can enter, right? That is how it is operating. Only difference is in counting semaphore, even it can take negative values, but here only 0 is allowed, not even negative values, right? Now see this. It contains a structure. One is the value which can take 0 and 1, 0 or 1, and the other is a queue. So you know what about a queue. So what is a queue? It is simply going to contain all the processes, the PCBs which got blocked because of unsuccessful down operation, just like counting semaphore, right? So L contains all the PCBs corresponding to processes which got blocked while performing the down operation unsuccessfully. And then let's see the down operation. Now when we try to do the down operation on binary semaphore S, if S dot value equal to 1, what does it mean? If the semaphore value is 1, right, so it means that the semaphore is still available, or it means that no one has entered the critical section, right? If S dot value equal to 1, which means no one has entered the critical section, and the initial value of semaphore is 1, and now also it is still 1, so no one has entered it, or someone has entered it and that process has even left, therefore it is still available and you can perform a down operation successfully. What does it mean? S dot value equal to 0, and you need not block yourself, you can come out. So if this down is performed before doing the entering this CS, and if its value is initially 1, the process which is calling this down operation will successfully enter the critical section, right? Otherwise, which means if S dot value is not equal to 1, then what its value will be? 0. It means that already someone has tried to enter it and he might be still inside the critical section. Therefore, you put the PCB in S dot L, which means that semaphore dot list, you put it there in the list and then you go and sleep, so that later someone will wake you up. Now what is up is, any process which comes out of the critical section should wake up the other process if there is someone waiting, otherwise it can simply go out. Now watch it. If S dot L is empty, which means that list is empty, no one is waiting, then S dot value equal to 1. So it is simple and so precise that you just understand it. If S dot L equal to empty means now you are trying to come out of the critical section and there is no one who has tried after you to enter the critical section, which means you are the only process who has entered the critical section and now you are trying to come out. Therefore once you come out, no one wants to get into it, as well as no one is inside the critical section. Therefore you again put S dot value equal to 1, so that later if someone tries to get into the critical section, they will successfully get into it. Are you understanding this? It is somewhat difficult to understand, just I'll repeat again. See, if S dot L equal to empty, it means that no process is blocked as of now. How is it possible? It is possible because no process has ever tried once you are inside the critical section. And now once you are coming out of the critical section, right, then it means that no one is blocked and no one has tried to enter the critical section and no one is inside the critical section also. Therefore you just make it as 1 so that later any process which tries to enter the critical section will directly enter it by performing a down on it. Else means s dot l is not empty. If s dot l is not empty, then what does it mean? That some process is already waiting for the critical section, right? Therefore select some process from s dot l and wake it up so that it can directly go and enter the critical section, isn't it? So that is how you can implement it, right? So let's see some questions on this, how the semaphore, this mutex is implemented. Okay.